Hello everyone, welcome to the next lecture on the PY question series. Today we will describe the Mobius transformation. Myself Dr. Harish Garg. We can discuss all those questions from these respective years paper. You can simply follow my YouTube channel where there is a playlist of the CSIR UGC NET, and you can see there is a topic wise complete PY question series available for you with the help of the shortcut tricks. So you can simply follow it and learn various tricks before going to the examinations. As I told you, my objective is to cover this topic bilinear transformation based on these respective years. We will cover 45 plus questions help of the shortcut trick. So let me quickly recall you some concepts and the shortcut tricks in advance before solving the PYQ. Any of the mapping is said to be the conformal mapping if the derivative is a non-zero inside the domain. For example, if I say my domain is collection of all those complex numbers apart from the origin, and if I say the mapping is 1 over z, then clearly says this mapping is non-zero for any z which belongs to this domain. So therefore this function is my conformal map. On the other hand, the collection of all those points at which the function is not conformal, like if I consider my map is my here and domain is my C, then clearly says what is the f dash of z, 1 minus here. So therefore you can see f dash of 1, f dash of minus 1, both are my 0. So it does not satisfy this property. Therefore 1 and minus 1 are my critical points. Next concept is called as the bilinear transformation, or we call as the Mobius transformation. Any of the transformation of this form is said to be a Mobius transformation if AD minus BC is my non-zero. If AD minus BC is my non-zero, then the real axis of this W or the Z is mapped on the real axis of W. If AD minus BC is my greater than 0, then the upper half of the plane Z is mapped on the upper half plane of the W. That means if you have the transformation of this W, of this Z, you have the transformation of the U and V of the W. If you map them, then the upper half of this, that means which are shaded here, it also shaded on the upper half. If you have the lower half mapping, then it map on the lower half mapping if this satisfies. On the converse, if it is a less than sign, then the upper half will map on the lower half. And this is a very, very important concept for this CSIR examination. Another concept is you have to take the mapping. If this is the mapping which we have defined here, then where lambda is any real number, then the unit circle is mapped on the unit circle of W. Inside circle is mapped on the outside of the circle if this condition hold, and similarly for this case. Another concept is if you have defined this mapping, then if imaginary part, then the imaginary part of y0, that means y is equal to 0 means that is the x-axis, real axis. Then the real axis is mapped onto the unit circle. If imaginary part of alpha is my positive, then this y is equal to greater than 0 is mapped on this, and similarly for here. Every bilinear mapping of the circle is, if you have the circle, is either map on the circle or it's map on the straight line. What is the meaning of that? If you have the mapping from Z to W, then if there is a circle in the inside this XY plane, then it will map either on the circle, or it will be the straight line, either pass to the origin or not. The last concept is a normal form. If you have the fixed point alpha and beta of the transformation, how you find the fixed point is, if you have the transformation this, then you can find the fixed point by taking f of z is z. For example, if I say my transformation is z over z minus 2, then the fixed point will be, I can take z over this one. Now if you solve them, you will get as the two roots of this z. So I call as a alpha and beta. If you have the two finite fixed value of alpha and beta with the condition that of this form, or you can say if any one of them is infinity, then if it is of this form, then if you prove that k is my 1, then this transformation, this Mobius transformation az plus b over cz plus d is my elliptical. If you prove that k is my positive but not equal to 1, because 1 is already here, then the transformation is the hyperbolic, otherwise is called as the loxodromic if it is form of the complex number. On the second case, if you have only the one fixed point which is written the transformation in this form, and if alpha is my infinity, then it is of this form, then this transformation is always called as the parabolic. Whenever you have the one fixed point, it is always the parabolic. Now let's start with this transformation. Always remember, whenever there is a question of the Mobius transformation, you always draw the diagram firstly. Look at that, how you can draw the diagram of this H positive, collection of all those xy where y is my positive. So this is my H positive. Look at this next one, H negative is collection of all those y's where y is negative. Y is negative is my second, third and fourth quadrant. Then L positive is x is my positive here. Then L negative is x is my negative. Fine. Then what is that tips I had told you? If AD minus BC is my greater than 0, then the upper half will map on the upper half, lower half will map on the lower half, right half will map on the right half, and the lower half will map on the lower half. This is the lower half, this is the right half. Now what is the AD minus BC? I can written this is Z minus 0. So what is the AD minus BC? 1 minus 0 is 1, which is greater than 0. So this is my upper half. Is there any other upper half? No, because this is the upper half and the lower half both. So it means H positive is map on the H positive itself. H negative is map on the H negative. L positive is a right half. There is no right half. There is no left half. Because this is my first and second quadrant. This is the first and the fourth quadrant. So now you can see the answer. H positive map on the H positive, fine. H negative is map on the H negative is the right answer. H positive map on the this wrong. H positive wrong. This is a wrong. So right answer is A is the right answer. Look at this another one. Again, this is the Mobius transformation. You can draw it graphically. Its a center is 1, radius is 1. So it's my circle. This is my 0. This is my 2. Here is my 1. Fine. Now there is no need to take as x is my iota y, substitute here and solve it. I will tell you the simple shortcut tips. Take any point inside this region. Take any point in this region. I called z is my 1. Fine. Z is the inside region. Then what is the value of the fz? That is w. What is the value of this? 2 over minus 1. Minus of 2. So w is my minus of 2. If w is my minus 2, what is the real part of w? Minus 2. What is the imaginary part of w? 0. Now look at that. He said imaginary part less than 0. One counter example disproved. Real part is positive, but we get a negative. Imaginary part is greater than 0. Again cancel. Only left option is my A is the right answer. Remember, you can't correct this option based on this example. Examples are provided to discard the option. If all are discarded, only one is left, then it's a right answer. Look at this another one. Again there is a mapping, so you can draw it graphically. This is the H positive. Imaginary part of Z means Y. Y is my positive. Y is my positive means this is the portion. H negative is Y is my negative. R positive, real part of Z is my here, and R negative means real part of Z is my negative. Now what is the transformation is? There is a positive transformation. So H map, there is a upper half, there is no other half. So it is a mapping on this. This is also same mapping as in the first example. So H map to the H map positive, H map to this is a wrong, R positive to R positive is the correct option, are A and C. Look at this another one. Again, this is my first case. Y is negative, this is my second case. X is positive, this is the third case. This is my fourth case. So what is that? AD minus BC. So 6 minus 5, 1 greater than 0. So H positive will map on the H positive, H negative will maps on this. H positive map on the H negative, wrong. H positive, wrong. This is wrong. So only right answer is my A. You can see within a 10 seconds you can solve the problem. But make sure you have to draw it graphically. Always draw the graphically representation. You may see I will draw each question graphically. Okay, look at this one. Which of the following statements are correct? Again, we can start with the graphically representation. First option, Z circle. It's a unit circle, open unit circle of this. Fine. And on the right hand side, it is a real of Z. Real of Z is X is a positive. So that is my here. Fine. Always remember, whenever you have the Mobius transformation, fine, if you take the inner point always map to the inner point. Fine. Second point is, if you take the outside point, then it maps to the outside point always. And third is, if you take the boundary point, then it map to the boundary point. Fine. Then which of the following is or are correct? So this is a circle of here. Take any point inside it. This is the point inside. If I take Z is my 0, what is my f of Z? F of Z is my 1, which is W. So what is that? Real part is my 1, which lies here, which is also the portion of the shaded region, and it satisfied this property. Look at the second option. It's again a unit circle, open unit circle, but imaginary part is my positive. So imaginary part is positive means this is my circle. Fine. It means this is my region of this. And what is the right hand side is? That is the X is positive, Y is positive. That means my first quadrant. Fine. Now take any point inside it. Say 0. So if I take Z is 0, what is the f of Z? 1, which lies here. Fine. It lies in the shaded portion. Or this is the inside point. If you take outside point, say here, if I take Z is 2, what is my f of Z? It's a 3 over minus 1. Minus 3. Where is the minus 3? Minus 3 lies here. This is the outside point. It map on the outside point. If I take the value on boundary point, if I take Z is my 1, then what is my f of Z is? Infinity. And you can see infinity lies on the boundary. So it means it satisfied all these properties. So it's satisfied here. Same for this case. If I take outside point here, if I take Z is 2, again f of Z is my minus 3. So minus 3 lies here. Outside point lies on the outside. If I take f of 1, what is the Z is 1? It is infinity. It lies on here. So it is again boundary point map on the boundary point. Look at the third case. Again a unit circle, but imaginary part is my negative. So that means this is the portion of here. Clear? This is my figure, and it maps to the X is negative, Y is negative on this. So again, if I take Z is equal to 0, what is my f of 0? F of 0 is my 1. Where is the 1 lies? Here. And you can see 0 is my inside point, but 1 is my outside point. So it is not transformation. Inner point must map on the inner point. So this option is cancelled out. Look at the last option. It's outside circle. Fine. This is the outside circle. Z is greater than 1, and it maps on the imaginary part of Z is positive. That is my here. So if I take any other point, let's say you can take any point. Let's say f of okay, I can take the inner point firstly. F of 0 will be 1. So I can take inner point. 1 is my, what is that? 1 is my boundary point. This is my boundary point, but inside point must map to the inside point. So this property not satisfied. This option is cancelled. Otherwise, you can also take the outside point. If I take outside point is my 3. What is the f of 3 is? It's a 4 over minus 2. That is a minus 2. Again, it lies on this boundary point because the imaginary part is 0. So it's again on the boundary. So that's why The correct options are A and B are the right answers. You can simply scan and join my WhatsApp group if you feel it's a interesting videos. Okay, look at this another one. Again, some mapping is given to you. We can draw it graphically. What is the graph of the first part? Collection of all those jets such that it's a unit circle. Fine. Then it maps onto the again a unit circle of this. Fine. Now, but the thing is, we have to apply, take any element. This is the inside. So what is the feasible area is this one. Take any point inside this domain. I take as a 0. What is my phi of 0? Because I take any point here is 0. So phi of 0 is 1. So where it lies? 1 is lies on here, which is a boundary point. Fine. But 0 is my inside point. So it means it is not the subset of this, because it not preserved that. Look at this second point. Take any point. What is the figure of this? Real part of z. That means x is my negative. So x is negative is here. Fine. You can take any point in this region. So I can take, say, z is my -1. Fine. If I take z is -1, what is my phi of, okay, and it maps onto the, it maps on again onto the same region. Is it the subset of this? We can see what is the phi of z is. If z is -1, it is 0. So where is the 0? 0 is again on the boundary, but he said it's a strictly less than 0. It is not the part of this domain. So -1 belongs to this, but it is it a subset of this? It is not the subset of this. This option is again cancelled. Phi is onto. What is the domain is? Phi is my onto. So how you can draw this graph? It's a collection of all those points apart from this one. It is not the part of this, and this is the complete domain. Fine. This is the mapping of phi. How you can prove the onto? I can take, okay, very simple. If I assume any of this, say, you can see this value becomes a 0 at -1. So what is the happening of this? 1 plus z over 1 minus z is, can you get any of the values of the z? If you multiply them, it will be 1 is equal to -1, which is not possible. So what does it mean? It means that this map is not onto, because you are unable to get the value of the z whose image will be, or unable to get the values of the z from here, which will be here. So this option is cancelled. Only correct option left is my D is the right answer. And also you can see this is a C minus of -1. There is no image of this as -1. Okay, let H is the upper half plane. Draw it graphically again. Y is my positive. Fine. Then which of the following are my true? Which of the following belongs to this? Now look at that. This is the upper half. Fine. So when it will be mapped to the upper half? When AD minus BC will be positive. Fine. So I can look at the AD minus BC is a positive. So look at that. For this case, I can return this as a 0z, 1z plus 0. So what is the AD minus BC? So 0 minus 1, which is less than 0. It means the upper half will map to the lower half, but it means this point does not belong to the H. First option is cancelled. It is a z square, but we need a linear. We will discuss later on. For this case, if I discard all this option, then this will be the right answer. If I see what is the AD minus BC, A is my -1, D is my 1, B is my 0, C is my 1, which is -1. So this is the lower half plane, but we need a upper half plane. So this option is also cancelled. Look at the third option. What is the AD minus BC? It's a 1, 1 minus 0 into 2. It's a 1, which is a greater than 0. So it mapped upper half to the upper half. This must be the true. Now look at this one, because it may have more than correct option, but it is not a linear function. So we can't apply the AD minus BC. So what we can do, I can choose any of the z which belongs to the H. I can take any number here. So this is the number. Fine. So what is the coordinate of this is 0, 1 or called as a iota. If z is my iota which belongs to the h, what is my 1 over z square? It is 1 over iota square. It's a minus 1. So where is the minus 1? What is the imaginary part of, what is the y? What is the imaginary part of 1 over z square? It is 0, but we need a strictly greater than 0. So this property, it is not strictly greater than 0. So this option is cancelled. Right option is only D is my correct answer. So this is the way simply you can use the concept of the upper half to upper half. There is one more way you can solve this problem. I will explain you this also. So what you can do is second method. If you are not able to do the graphically, but what you can do, you can choose any point in this case. Let's say z is iota. Then what is the first option? 1 over iota. What is that? It's a minus iota. So what is the imaginary part of this number? Is a minus 1. Does it satisfy to be greater than 0? No. So it means this option is again cancelled. Again, if I take any number in this plane, that's a z is iota. The second part is 1 over, which is a minus 1. So what is the imaginary part of 1 over z square, which is 0, which is again not greater than 0. So this option is also cancelled. Again, if I take z is iota, then it is minus iota over iota plus 1. So what is that? If I rationalize it, it is a 1 plus iota, 1 minus iota, and this. So the denominator will be 2. This is a minus plus, it's a minus 1. So what is the imaginary part of this? Minus half, which is again not greater than 2. So this option is also cancelled. Only the left option is my D is the right answer. So you can use any way, either upper half to upper half or this substitution method. Okay, consider the Mobius transformation which circle is passing through here. Okay, so as I told you earlier, so circle under the transformation will map either circle or the straight line. Fine. Now what is given to you? See the circle which has a positive radius. What is the radius? It is not given, and passing through the origin. What is the meaning of that? Passing through the origin. If I consider here, or you can consider this is my radius, positive radius, then it will be my here. Fine, it passing through the origin. Fine. Now take any point inside it, say 1. Fine. So my target is, I consider this is a circle, then this is on the xy plane, then we will see what is the mapping on this u and v. So take any point inside it, or yes, take any point inside it. So this is my z is 1. So what is the f of z? It is my 1. Fine. Where is f of 1 is? That is a real axis, imaginary axis 0. So this is my real line, because imaginary component is my 0. So is it a circle? No, it is not a circle. It is a straight line. So first option is circle is a cancel. It is a straight line, because it either this or this. If you take inside point, it's a straight line. Now whether the straight line is this passing through the origin or not. How you can prove that it's a passing through the straight line or not? So we can write the equation of the circle: a x square plus y square plus bx plus cy plus d is equal to 0. Now since it is the equation of the circle, so it means a is my non-zero. It passing through the origin, so definitely d will be my 0. And you all knows what is the equation of the straight line. If you write here, you can transform this the reverse, that is a u square plus v square plus c of u plus b of v plus a of here. Now since d is my 0, so this value will be 0. So what is the meaning of that? cu plus vv plus a is my 0. Now since a is my non-zero, so this is my non-zero. So what is the meaning of that? This is a straight line. Since a is my non-zero, so it is not passing through the origin, because if it passes through the origin only when this constant value will be the 0. So it is not passing through the origin is the right answer, passing through the is a wrong option. So what are the correct options? B and D are the right answer. Look at this another one. Fz is my here, which of the following are always true? That's a more than one correct option. Okay, what is the analytic function? Okay, we have to check the singularities. So what is that? Clearly says the only singularity is my, what is the only singularity of the z? Is z is 0. Make sure student, it doesn't mean that z does not belong to the domain. Domain is a complete complex number. Z is not 0 is defined for the well defined function. Fine, it doesn't mean that the domain is my c minus 0. It doesn't mean that. Fine. Now the only singularity is my f of the f is z is 0. What is the meaning of that? F is analytic everywhere for all those z which is apart from this 0. So the first option you can see, f is analytic on this domain. Second is conformal mapping. What is the meaning of the conformal mapping? As I told you, if you find this is my non-zero for all those z in my domain, so domain is my c minus 0 because the function is analytic on this domain. So can you find the f dash, which is 1 over, so clearly says f of 1 is my 0, f of minus 1 is also 0. So what is that? It belongs to this domain. So what is the meaning of that? It is not conformal mapping. Look at this another one. F maps. Once is a map, you can draw the diagram. Unit circle. This is my unit circle. It maps to the real line. They map on the real line. That means here. Fine. So again, I can take any of the inside point. Say z is 0. What is my f of z? It is infinity. Where is the infinity lies? On this case. If I take on this point, what is the point of this is? Iota 0, 1. So if I take z is my iota, then what is my f of z? Iota plus 1 over iota. So this is iota into iota. It's a 0. So this map is on this. So what is that? It's a straight line because it's not a circle. Because first of all, it's a fz is infinity. So definitely it's a straight line. It is not a circle. Why? Because infinity is not a radius. So it means it's a straight line. F map this one. And image of any circle in this is again a circle. It's a wrong option. Why? Because if I take iota as the point, it maps onto the 0, and 0 is not be the radius of any circle. So it is again a circle, is a wrong option. So right answers are my A and C are the correct answers. Look at this another one. If H is the mapping, if I draw the graphically of this, Y is my positive. This is here. Okay, so I can draw here. H is my positive. Fine. It and D is the mapping of the unit circle, open unit circle. This is my D. Then if F is a transformation which map H to the D such that F of 2 iota will be 0. Where is the 2 iota? It lies here. Fine. X is my 0, Y is my 2. This is my 0, 2. So it maps on the 0. Fine. Such that of this, which of the following is my correct statement? Oh, very simple. You can see, if you look about that, what is the meaning of that? F is a map from upper half to the circle. This is given to you. So as I told you, the shortcut tricks for the only map which transforms from the upper half to the unit disk is of this form. So therefore, this mapping is of this nature. So I can write this as e raised to power iota z, z minus alpha over z minus alpha bar. Fine. Now our target is to find the value of alpha. So clearly says, what does it means? If I apply f of 2 iota is 0, so what is the means? Alpha must be 2 iota. So what is the meaning of that? This mapping will be my 2 iota divided by here. Fine. Now we get a map. Once we get a map, now it's very easy. F is a simple pole. Clearly says Z is equal to 2 iota. Z is 2 iota is my simple pole. Fine. So if this is first option is correct. Once it's a simple pole, what is it means? It is not essential singularity because it is a simple pole. So third option is cancelled. Look at this one. F of iota. If I substitute here, it is lambda is unknown to you. I can written here. What is the iota? It's a minus iota divided by 3 iota. So it is minus 1 over 3. What is the f of minus iota? It is e raised to power here. If I substitute minus, it's a minus of 3 iota divided by iota. It's a minus of 3. Now you can substitute here. So e raised to power iota minus 3 into complex conjugate of this. So complex conjugate is my minus 3. So this is cancelled, minus minus cancel. 3 by 3 is 1 is the right answer. Look at the last option. 2 plus 2 iota. So it is e raised to power here. What is the 2 plus 2 iota? Is my 2 and it is my 2 plus 4 iota. Now take the absolute value. What is that? If you take the absolute value, e raised to power will goes to the 1. It is my absolute value of 1 plus 2 iota. So it is a 1 over 1 plus 4. It is 1 over root 5. So you can see how many seconds you are needed to solve the problem. So that's a simple apply the shortcut tricks as I mentioned you earlier. Okay, now look at this. Capital D is a mapping of the unit disk. Fine, this is my capital D. And let's see what is the C is. C is the any complex plane. So that is my here. Fine. So which is given to be here. What is that? If you closely look, this is a mapping of here. Z minus alpha, alpha bar, Z minus 1, which is same. Only thing is I can multiply and divide by, you can see it's a Z minus alpha, alpha bar. So this is the same of this. A bar Z minus, I can simply take negative as a common. Fine. Now you can see which is of this form. Then which of the following is or are true? So first option is if Z bar is my 1, then it maps onto there. So look at that. If I take Z is e raised to power iota theta, what does it mean? This is my 1. So what is that? It lies on this D. So therefore this value is in my D. So according to this rule first, it maps onto the W is y1. So what is that? This is f of Z is my 1. What is that? This is, it is a correct statement. So this is the right answer. F map unit circle onto itself. That's a wrong option because it maps onto instead of into. So this is itself. That means you can see this map onto the itself. So what is the meaning of that? This is unit circle. It map onto the unit circle, but it's on the into if this condition hold. So is it true? What is that? Nothing is given to you, but it is not onto. It is here. So A can be any number. A is in the domain. So you can see if A is the domain, what is that? Mod of A is less than 1. If mod of A less than 1, this condition satisfied. Hence this is my, this option is correct. This option is wrong. Now how you can prove that it's a 1-1? A very simple rule I can tell you. Every Mobius transformation, or you can say every bilinear transformation, is always 1-1. Fine. So you can see or you can remember this. So this is also correct option. A, C, D are my correct answers. Okay, look at this one. Capital D is the mapping from the open unit disk to open unit disk. Capital D to capital D. This is the mapping of FW. Then, and it's an open unit disk. So it's the inside portion and it is also the inside portion. Now look at that. What is, which of the following? First of all, it's a bilinear transformation. Fine. and every bilinear transformation is 1 1. So this option is cancelled. Now clearly says if you take any element of this, fine, if I consider this is my A, then definitely each element will be existence in the B. So it is a onto mapping. Clearly say every element map on this. So it is a onto mapping, it is not onto. So clearly says if you draw it graphically, you will get the right answers in a very simple manner. And you can see it's a June 2019 paper. How many seconds you are needed? Hardly a 5 seconds you are needed to solve this problem. Okay, a bilinear transformation is given to be here. Now they are not talking about the upper half, lower half. Okay, the one way is, if you remember, you are using the cross ratio. What is that? W minus W1, W minus W2, and so on. Similarly, Z minus Z1, and so on. There is no need to solve like this manner. I will tell you the simple shortcut tricks for solving such problems. What is given to you? Whenever Z is my 0, then W will be my minus iota. Whenever Z is my 1, W will be my infinity. Whenever Z is my infinity, W will be my 1. So look at that, which point is not satisfied. Look at that, whenever Z is 1, it is not infinity. Cancel. Whenever Z is 1, it's a 1 minus iota over this. It is not satisfied. It is satisfied. It is satisfied. Now look at that, whenever Z is 0, it is 0 plus iota over minus 1. It is a minus iota, satisfied. If it is here, it is my 1 over minus 1. It is minus 1. So when Z is 0, we need a minus iota, but he said plus 1 is a wrong option. Correct option is my C is the right answer. You can solve it, you can check whether the other options are satisfied or not, but it is automatically satisfied because we discard the rest of the options. Okay, look at this again. Again, I can apply the same shortcut tricks here. Whenever Z is my 2, my omega will be 1. So firstly, we can check it. So first option is 6 minus 2 iota over 2 iota minus 6, which comes to be minus 1, but we need a plus 1. So this option cancel. Look at this one, 6 minus 2 iota over 2 iota plus 6. It can never be a 1, but we need a 1. So this option is cancelled. Look at this option, it's a 6 plus 2 iota. This is 2 iota minus 6, again, which is not equal to 1. This option is also cancelled. The right option is my D. We can check it. 6 plus 2 iota, 2 iota plus 6, which is 1. If I check on the second point, Z is iota, then omega must be iota. So if I substitute, here is iota, 3 iota plus 2 iota is iota square plus 6. So 5 iota divided by 5 is again iota. Similarly, if you take Z is my minus 2, omega must be minus 1. Although there is no need to solve, but I will tell you if you want to solve it. So if I take Z is 2 minus 6 plus 2 iota minus 2 iota plus 6. If you take negative common from the above, it comes to be minus 1. So the right answer is my D is the right answer. Okay, look at this one. P is a polynomial of the one variable. So that means Z minus alpha. Fine. And the zeros of the Z are in the upper half plane. So I can draw the graph of this. Imaginary part is my here. Fine. So what is the zeros of this? P of Z is 0. It means Z is my alpha. So alpha is lies here. I can choose any number here. So I can choose simply iota, or you can choose as a 2 iota. It's on you. So what is the meaning of that? I can choose alpha is any number is in this shaded portion. Fine. It's a strictly greater than 0. Fine. You can choose any of the alpha. You can choose any number in this case. So what is the P dash? 1. Then which of the following property is satisfied? So imaginary part of P dash over P. We will check whether it's a greater than 0 or not. What is the P dash is 1? It is Z minus iota. So what is that? It's a 1 over x plus y minus 1 of this. So what is that? If you rationalize them, what is this? This is x, sorry, it is a root. Okay, that's fine. Okay, instead of that, if I simply take, okay, fine. So if I simply take, this is my y minus 1 of alpha divided by x square plus y minus 1 whole square. Fine. Now what is the imaginary part? Is minus of divided by y minus 1 whole square plus of x square. So it comes to be 1 minus y divided by of this. Can it be greater than 0? Oh, sorry, I forget it. It's a z is r. There is no need to solve like this way. I forget to check it. For all z in the r. Okay, so if z is in the r, what is the meaning of that? I can simply take z is x. Fine. So what is that? It is the imaginary part of 1 over x minus iota. So what is that? If you solve them, it is x plus iota divided by x square plus 1. So what is the imaginary component? Imaginary component is my, and clearly say it is a greater than 0 for all x. It means the first option is correct option. Look at the second option. A real part of iota times p dash over p. So p dash over p for all z in R. So this is the expression we have obtained. Fine. So what is the real component of this? If you multiply them, it will be minus 1 over x square plus 1, which is always less than 0 for all x. It means this option is also correct option. Look at the C option. For all the z in the C such that y is my less than 0. So can you assume any of the number which is less than 0? I can simply choose z is minus iota. It satisfies this property. Then what is my imaginary part of p dash over p? So what is that? P dash is my 1, z is my minus iota. Fine. So what is that? It is minus 1 over 2 iota. So if I rationalize them, it is my iota divided by 2. So does it always greater than, it is a greater than 0? Yes, it is greater than 0, because what is the imaginary part of this? Half, which is greater than 0. Satisfied. Look at this one. Collection of all those z in the C such that y is my greater than 0. I can take z is my iota because y is my 1. So what is the imaginary part of 1 over iota minus iota? So what is that? It's the infinity. What is the imaginary part? Imaginary part is my 0. So but he said strictly greater than 0, but it is not greater than 0. So this option is cancelled. A, B and C are my correct options of this problem. Look at this another one. It's 2020. For the positive real number C, consider the locus of all those points such that z minus iota, z plus iota will be C. Which of the following statements are my true? Very simple. Look at the options. Firstly, C. Firstly, we will take here. Choose any number which is less than of the 1. I can choose C is equal to 0. What does it mean? It means z minus iota must be 0. Fine. What does it mean? Z is equal to iota. Fine. So if z is equal to iota, it means x is my 0, y is equal to 1. So graphically it lies on here, that is on the y axis. But look at the option. Locus is a circle. Locus is a circle, but it is not a circle. It's a lies on the y axis. So this option is cancelled. If C is equal to 1, if C is equal to 1, what does it mean? It means z minus iota is z plus iota, and if I open this is x y minus 1 iota, or is equal to x plus y plus 1 iota. Okay, then you can simply take the modulus. It will be my x square plus y minus whole square is x square plus y plus 1 whole square. So what will happen? If you open this bracket, it will be minus of 2y. It is plus 2y, means y is equal to 0. So y is 0 means it is a x-axis, that is a real axis. So if c is equal to 1, locus is a straight line parallel to the imaginary axis. Parallel to the imaginary axis, that is a wrong statement, because we will get as a real line. Is a straight line not passing through the origin, but what is the x-axis is always passing through the origin. This option is cancelled. Only left option is my A is the right answer. And you can easily prove that. You can take any number of the C, say 2, substitute here and so on, but there is no need because we already discard the rest of the options. Okay, now look at this another one. How you can think about this? There is a point, capital D is an open disk which lies on here. U is my point, which is capital D minus half to half. D is the open unit disk. Fine. U is the all those points apart from minus half to plus half. That means this is my I can say this is critical point. H1 is a mapping holomorphic and bounded. H2 is also homomorphic and bounded, that is analytic and bounded. R is a mapping from this to this given by restriction. Okay, for 1 1 and on 2. Very simple. If I start from the 1 1, what is the meaning of that? If I take the two mapping R of F and R of G as of this, what does it mean? F mapping of U is equal to G mapping of over the U. That means F mapping of U minus of this is 0, and 0 is the part of the U. So what does it mean? F minus G is my 0 on a set U. So what is the meaning of that? F minus G is my 0 on this set D. So what is the meaning of that? F is equal to G on this D. So what is that? H1 is a mapping of this. What is the meaning of that? It is my 1 1. So F is injective, F is not injective, cancel. F is not injective, cancel. Now look at this onto. How you prove the onto? I can take any element in this G is any element in my H2. What is the meaning of that? H2 is my holomorphic and bounded. G is my holomorphic and bounded on the U, except minus half plus half. Fine, but you can clearly say this minus half and plus half points, because these are my, you can see simply say is a removable singularities. Fine, because it's open disk, you can easily remove them. Once it's a removable singularity, then we all know we can extend them. We can extend this mapping onto the holomorphic mapping, as well as G is also the bounded. So we can extend them, this mapping, to the analytic function on this capital D. What is the definition of this? F is a holomorphic and bounded on the capital D. It means this G is belongs to the H1. So what is the definition of this? What is the meaning of that? Or you can say, I already say, so I can extend this to the any say Q. So it means Q is a part of this. So therefore we can say there exists a Q, so that it becomes my G. Hence it is onto as well. So it is not onto. C is the right answer of the problem. Now we will look about some question on the gate examinations. That's again a very simple. We will approach the same way. We firstly draw it graphically. Center is my minus 1. Radius is my 1. Fine. This is the mapping of this. This is a minus 2, 0, minus 1. Consider the transformation of this. Oh, very simple. Take any point in this region. Can you think about any point? I can choose Z is my minus 1. Fine. What is the mapping of this capital W? If Z is my minus 1, it is a minus 1 plus iota plus 2 divided by minus 1 minus iota plus 2. It is a 1 plus iota, and it is 1 minus iota. Either you can rationalize it, otherwise you can write in the quadratic, in the polar form. It is my iota pi by 4, and this is here, it is my iota minus pi by 4. So what is that? It is iota pi over 2. What is that? It is iota. Fine. Or you can rationalize it also. So it is 1 plus here, and this is 1 plus 1. Again it is come to be the iota. So what does it mean? Okay, and second is, I can substitute in the second case. It is minus 1 minus iota plus 2, and it's a reciprocal of this. If you look about that, it's a reciprocal of this. So what is the value of, if I call this is my W2 and this is my W1. So what is the value of W2 is 1 over iota. It is minus iota. Now look at that. For the first case, it is my iota. For the second case, it's a minus iota. So look at that. Imaginary part, what is the imaginary part of W1? But he said less than 0. Wrong option. Imaginary part is greater than 0, satisfied. What is the imaginary part of W2? It's a minus 1. It's satisfied. But we can't say that for this counter example. What is the W1 magnitude? It is my 1. But he said greater than of the 2. Wrong option. What is the magnitude of W2? 1. But he said greater than 1. Again it disqualified. Only left option is my B is the right answer. You can see, you always draw the graph and pick the point from it and discard the options. Okay, look at this another one. F is a mapping which is defined as here of this. Which of the following statement are my false? Is a conformal mapping of this. Firstly, you can clearly say is the only singularity of this is, what is the singularity? Is minus 3 over iota, or you can say it is 3 iota. So it means f is my analytic function over the domain C iota, and already it is given that here. Fine. So once f is analytic, how you can prove that it is? It means f dash of this always exists in this domain, because 3 iota does not exist. Otherwise you can find the derivative and clearly says f dash of z is my non-zero for all z. What is the meaning of that? It is my conformal mapping. So f is my conformal mapping is my true statement. Fine. Now once it's a conformal mapping, what is the meaning of that? If it is an analytic function, then it maps circle to the circle. Fine. Or you can see, if I take f map circle in this, I can simply say here apart from the 3 iota. Fine. Then f map, because it's a conformal mapping, so then it maps circle to the circle, straight line to the straight line. So this option is also correct option. Now look at this one. All the fixed point of the f are in the region greater than 0. So how you can find the fixed point? I can simply take this number to be z. So if I open this bracket, I can say iota z square plus 3z. Now it's a quadratic equation, plus 2z plus iota is 0. So what is the fixed points are there? So minus b plus minus b square minus 4ac is a plus, and 2 iota. So it is minus 1 is a 8 root 2 over iota. So if I multiply them, it come to be 1 plus minus root 2. Fine. Now what is the imaginary part of z? It is plus minus root 2. It is always greater than 0. This is my false statement. So since there is only one correct answer of this, so it means this is my C is the right answer of this problem. Look at this another one. The image of the region, real part is x, imaginary part is y. X is my greater than y. That is, this is my here. X is my greater than 0. So this is my portion available at here. Fine. Then you have the mapping from z to e raised to power z square. So I can simply choose here. Then what is my z square? It is x square minus y square plus 2xy iota. What is the e of z square? I can simply say x square minus y square, and it's the e of this I can written in the terms of cos xy. Fine. Now you can choose any point in this region and check about this. First part is whatever the real part is greater than 0, imaginary part greater than 0, real part greater than 0. Simple. Look at that. There is a term of the 2xy. You can choose x and y from here such that x is greater than y, and can you choose any of the number, because exponential part, this number can never be negative. Fine. So this is always positive. If you prove any counter example, real part greater than 0, can you choose any of the x and y in this region so that cos of 2xy either less than 0 or is equal to 0, because we need a strictly greater than 0. Can you choose x and y? If I choose any point here, like say 3, 0, so 3 is greater than y, satisfied. Cos of 0 is 1. So in the first quadrant, this value will be 0 only when it will be pi by 2. Fine. Only when it is a pi by 2. But where is a pi by 2? Where is a pi by 2? Okay, or if I can, okay, fine. If I choose x is my 2, fine. What should be the y? So that this value will be 0. X is my 2, it's a 4. So sine of 4, it will be 0 only if you multiply this by pi. So, but pi is my 3.14. It not satisfied. So I can choose this number to be more than of this. I can choose x is my 4, y is equal to pi. If I substitute here, what will happen? It's a 4 minus pi square. It's always a positive number. It's a cos of 8 pi plus iota sine of 8 pi. So this number is my 0. Cos of 8 pi is my plus 1. E of 4 minus pi square. So clearly says what is the imaginary part of this, which is 0. But he said greater than 0, option cancel. He said greater than 0, option cancel. He said greater than 0, option cancel. Right option which is left behind is C is my right answer. Look at this another one. What is given to you? R, E, real and imaginary parts here. T is the mapping of the bilinear such that T of 6 is my 0. T of 3 minus 3 iota is my here. T of 0 is my infinity. And image of this. Very simple. I can draw the graph of this. Center is my 3. Radius is my 3. Fine. This is 6. This is 0. This is my 3. Now, in this case, firstly you have to define the mapping. Fine. How you can define the mapping is a very simple. If you closely look about this case, when you substitute 6, answer must be 0. So definitely it will be z minus 6. When you substitute 0, it becomes a infinity. So it must be like of here. Fine. So then the coefficient, what about the other? I can take the coefficient as a k. So can you find the value of k? I can use this third property. Fine. So if I use this third property, 3 minus 3 iota is here, which comes to be k. If I substitute here, it will be minus 3 iota minus 3 divided by 3 minus 3 iota. So 3 will be cancelled out. So what is that? Is iota is equal to k minus, I can also cancel out iota plus 1. I can take minus as a common, and this is minus 1 plus iota. Fine. So can you find the value of k? I can simplify it. Minus iota plus iota square is minus 1, which is k plus k iota. You can equate the real and imaginary part. K will be my minus 1. So your transformation will be my minus 1. So it's a 6 minus z over z. Fine. Now that's over. Now rest of the part we can take it and take any point inside this region. So what you can do, I can take z is equal to 3. Fine. What is the transformation of the 3? So 6 minus 3 over 3 is a 1. So what is that? Real part of this w is my 1. What is the imaginary part of this w is 0. Look at the options. He said imaginary part is less than 0. He said real part is less than 0, but we get a greater than 0. He said imaginary part is strictly greater than 0, but we get a 0. So the right answer which is left behind is D is the right answer. Okay, look at this another one. F is the mapping. Whenever z is my minus 1, it goes to the 1. Whenever z is iota, it goes to the infinity. Whenever it goes to minus 1, minus iota, it goes to the 0. Fine. Then your target is to identify it. Again, a very simple, I can define the mapping when it will be 0, when it is a minus iota. So it means it will be here. When it will be infinity, when it is a plus iota. So definitely it will be here. And for the last case, I can take it as a constant k. Now I can substitute this value in this case for finding the k. So this is my w. So it's a 1 when it's a minus 1 plus iota over minus 1 minus iota. So I can open this bracket minus 1 minus iota minus k plus k iota. Equate the real and imaginary part. K will be minus 1. So what is my f of z? It is minus 1 z plus iota over z minus iota. Fine. This is my bilinear transformation. You can verify it. This property is satisfied. Then what is the f of 1? That's over. What is that? It's a 1 plus iota over 1 minus iota. You can rationalize it. It is a 2 iota over 2. So this will cancel. It's a minus iota is the right answer of this. Is it true? It's a minus of iota. So this the minus is a is it you can check it deeply. Sorry, this is wrong because from here we get a case 1, but from here we get case minus 1. Sorry, this is wrong. So I just wait. So this transformation is not there. So I can simplify it. I can substitute here. Z is my 1, W is my 1, and this is minus 1. So iota minus 1 minus 1 minus iota. So I can take 1 minus iota over 1 plus iota. Fine. So I can change into this polar form. This is minus iota pi over 4, and this is root 2 e raised to power iota pi over 4. So this is cancelled. So it implies 1 is equal to minus iota pi over 2. So what is the e of minus pi over 2? So it is a minus iota. So what is that? K will be minus 1 over this. So k is my iota. Fine. So therefore my mapping will be iota times z plus iota over z minus iota. So now what is the value of the f1? So if I substitute, it's a 1 plus iota 1 minus iota. So it is iota times, if I rationalize this, it's a 2 1 plus iota square plus 2 iota. So it will be the cancel. It's a iota square. Iota square is my minus 1 is the right answer. So in this case you are unable to equate them because from the one side is a plus 1, is a minus 1. So it means we are using this polar form. Or moreover you can rationalize it also. There is no issue. Okay, look at this one. Firstly you can draw the graph. It's a unit circle of this. This is a capital D. Then it transforms to this. Again I can choose any inside point. Fine. So I can choose Z is my 0. What is my f of Z? That is a W. It is Z is my 0. So this value is 0. This is 0. 1 over minus iota. It is root iota. How you can find this value? So it is iota I can written as pi over 2 So it is e raised to power iota pi over 4. Fine. Now it means I can take, this is my inside point, so it must be the inside point. So okay, look at the graphical representation of the first plane. Argument is 0 to pi. This is my 0 to pi. Fine. But you can see, okay, fine, look at this one, is a minus pi to 0, but plus pi by 4 is lies here, so this option is cancelled out. 0 to pi by 2, it lies, so it may this or this. Pi by 2 to pi to pi, this one. 3 pi by 2 to 2 pi, but pi by 4 is lies in the first quadrant, so this option is also cancelled out. Now for these two options I can take any other point. So what is that? Pi by 2 is my here. Fine. Pi by 4 is my here. So I can take on the boundary point. So you can take any of the boundary point, either on this or on this or on this or this. So let's say I can take as a minus 1, or I can take as a plus 1. If I take 1, which is a boundary point, so then the mapping will also goes to the boundary point. What is that? This is 1 minus iota divided by 1 minus iota, so it comes to be 1. So if we write, what is the argument of this? If w is my 1, what is the argument of this? I can return this is 0 of 0. Fine. Is it true? Or any other value? Is a 2 pi, e of 2 pi. Fine. But you can see it is not lies here. So what you can do? Omega is equal to 1. So you are unable to find this from here. So I can choose, say, another point. Boundary point is minus 1. What is my w? It is a 1 plus iota, and this is minus 1 minus iota. So it is, what is that? It's a minus 1 and root, that is iota. So iota I can return as pi over 2. So this is the boundary point. Pi by 2 must be on the boundary. Pi by 2 must be on the boundary, but it is the boundary is pi. Cancel out. This boundary is my here. So the right answer is my C is the correct option. You can also see here, in this case 0 is my boundary point. So in this case 0 is the boundary, 0 is the boundary, but you are unable to get the result. So for this I can take another point. You may take this point also. This point is my iota. You can take this point iota as well. That's again will give you the same result. Like here, if I take z is iota, what is my this value? Iota minus iota is infinity. So what is the angle of infinity is pi by 2. This is the boundary point, so pi by 2 must be the boundary point. So it is not there. Pi by 2 is the boundary. So the right answer of this problem is C is the right answer. Okay, look at the upper half of the x, and this is y is greater than 0. Fine. Under a mapping of this case, very simple. You can choose any value of the x, any value of the y, so that this condition satisfied. I can choose x is 2, because there is no restriction on the y. Y can be negative, so it is my minus 1. If I substitute here, what is my z? 2 minus iota. Then what is the value of this? 2 minus iota minus 1, 2 minus iota plus iota. What is that? Iota minus this over 2. So what is that? What is the real component of this? Half. Imaginary component of this is minus half. So this value will be cancelled out. Okay, what is the absolute value of this? It is 1 over 4 plus 1 over 4. It is 1 over 2. That means root 2 over 2, which is less than 1. But he said greater than. So this option cancel. Now you have the two options left. Now look at the other pairs. If I choose x is my 1, then y will be 0. Then only is strictly greater than 0. So if I take here, what is the z? Z is my 1. If I substitute here, w will be 0. So if w will be 0, real component will not be greater than 0, but still absolute value is my 0 is less than 1. So the right option is D is the right answer. Look at this another one. This is the GATE 2022 mathematics exam. What is given to you? T is a Mobius transformation such that t of 0 is alpha, t of alpha will be 0, t of infinity will be minus of alpha, such that alpha will be here. Then L is a straight line which passing through here also. Now again you have to firstly find the transformation. What is that? Whenever it's a 0, it goes to the alpha. Okay, I can move on the reverse side. T inverse of alpha will be 0, T inverse of 0 will be alpha, and T inverse of minus alpha will go to the infinity. Fine. Remember, T is my Mobius transformation. This implies T inverse is also Mobius transformation. Now I can find the map of T inverse. Whenever it's a minus alpha, it goes to the infinity. Fine. Whenever it is a 0, it goes to the alpha. Whenever it goes to the 0, no. Yes, whenever it goes to the 0, it goes to the alpha. So it means it is my here. I can't take as a positive because it will be here. So it's a minus sign. I can rest of the part I can take as a k. Fine. And I can find the value of k by using this case. So t of alpha is my 0. Okay, I can find this value of k by using here. So what is that t inverse of 0? It is alpha. So what is the t inverse of 0? This is my minus 1. So it is my minus k is alpha. So k is my minus alpha. So therefore t inverse of z is my minus alpha, z minus alpha over z plus alpha. This is the mapping. Now we can find it firstly for here. C map. What is the C? C is the unit circle center at the origin and the radius circle is my 1. Fine. Take any point inside it. Say z is 0. What is my, sorry, this is t inverse of, yes, t inverse of z. How you can find it? When z is 0, what is that? It's a 0, it's a 0, it's a cancel out, it's a minus of alpha. Fine. What does it mean? Can you say? No. T map circle. C is the unit circle of this. It's the inside point. So where it lies? What is alpha? Alpha is my complex number. What is the minus of alpha? It's a 1 over root 2 minus alpha over root 2. So it lies here. It may be a circle. Fine. Okay, look at that. This circle is my unit length. So clearly say this is also the unit length. Fine. So it means this point is my alpha. Okay, fine. So if I say t of minus alpha, because minus alpha will goes to the infinity. Now once it's a infinity, it means it is not circle. Fine. It means it is a straight line. So it means t inverse c to the straight line is the right answer. T circle is the wrong option. Now second one is that t maps L to the straight line. Okay, now this is the mapping of the t inverse. We can define the mapping of t. So I can simply use, this is w. I can find this value. I can equate this over minus alpha, z minus alpha over z plus alpha. So I can find the value of the z from here, and which is again a similar of thing. So because why? I can simply say it's a 1 minus 2 alpha over z plus alpha. So what is that? Z plus alpha over 2. I can take on this side and it will be 1 minus alpha over this. It will be plus 2. So I can take the LCM and you can simplify it. Is there any other way you can do it in an easy manner? Okay, you can do, okay, instead of this you can start from, okay, this part is over. Now I can use this transformation. Fine. Because it's a Mobius transformation, so I can assume AZ plus B over CZ plus D. T of 0 is alpha, but okay, fine, B over D is my alpha. T of alpha will be 0. T of alpha will be, okay, T of infinity will be minus alpha. So it means A over C is my minus alpha. So what does it means? B over D is minus A over C. Fine. But there is no, but we can't find the value of A, B, C, D. Okay, I can use the same way. We are unable to find this. We find this transformation as minus alpha, Z minus alpha over Z plus alpha. Fine. So if I take, this is my, no, this actually this is a W, because it's a T inverse. W is my T of Z, so T inverse of W, basically this is a W, this is W, so this is W basically. Fine. Now this is my Z. Now our target is to find the map W, so it means I have to equate them. Can you find the value of W from this case? So you can easily find the value of W from this. So it is a minus W minus of this, and it is W minus alpha. So what is that? I can take on this minus Z here, which is W is common, 1 minus Z over alpha. So W will be alpha minus Z, and it will be, I can written here, and this will be this minus, where is the minus is, okay, this will be alpha minus Z into alpha. Is it correct? Well, it is a cancel out. Kindly check the calculation, where is a mistake. If I take as a Z minus Z over alpha, this, if I multiply this, it is my fine, it is a plus minus minus, alpha will be cancelled, it's here, it is correct option. So W is my alpha. Fine. L is a straight line passing through the origin with the slope minus 1. Passing through the origin is here. Fine. So okay, take any point on this, say beta is the point on this. Fine. If I say beta is the point of this, how you can say this value is satisfied or not? If beta is the point of this, how line, then if I substitute this value here, okay, fine. If beta is the satisfied, then still this transformation becomes alpha only, so it is never be a circle. Fine. Is it a circle? No, it is not a circle, because it's a constant value, so it can never be a circle. So this value is my here. You can check your calculation whether this calculation is correct or not. If it is correct option, then if this is the correct calculation, then I assume the A and C are the correct answers. Look at this another one. I can draw it graphically again. X is my 0, Y is my 0, X plus Y is my 1. So feasible area is my this one. Then the mapping of this case, then the angle of the intersection of this, so we have to find the angle. I can convert this into the polar form. Fine. So r square e raised to power 2 iota theta. So what is the argument of this transformation? It is 2 theta, where theta is the argument of this Z. What is the angle of this? It is 90 degree. So if I substitute here, what is that? It is pi is the right answer. If somebody asks you find the modulus of this, so what is the modulus is r square. So you can find the length of this is a unit length. You can say it's a unit length, then its value is here. So right answer is D is the correct answer. Is a gate 2021 is there. What is that? It's a bilinear transformation. Whenever Z is my 0, W will be my 10. Whenever Z is my minus iota, W will be my 5 minus 5 iota. Whenever Z is my 5 plus 5 iota, W will be my, whenever Z will be my infinity, W will be my 5 plus 5 iota. Fine. So my transformation will be here. Fine. Then how you can find the transformation? Again, because the infinity is given to be here, Fine. I can choose is a transformation of this. I can firstly modify this. How I can modify this? I can return this is tan inverse of W, because the value of infinity is given as a z, so I can return this in terms of here T inverse of 5 minus 5 iota is minus iota, tan inverse 5 plus 5 iota is my infinity. So based on this you can clearly say how I can define this. When it is a 10, it's a 0. So fine. Is it true? Whenever it's a 5 plus 5 iota, it is my infinity. Fine. And the rest of the thing I can return this as a this one. Clear? Everybody clear? Now how you can find the k? I can use this value. So it is minus iota 5 minus 5, sorry, it's a k. W value is my 5 minus 5 iota, so it is a minus 5 iota. If I substitute 5 minus 5 iota, is a minus of 10 iota. So what is that? It's a minus iota is a k. 5 will be cancelled out, 1 plus iota over iota. So if I multiply them, it's a minus iota square is a k times 1 plus iota. Or how you can solve this? Or k will be is a 2 times 5 to the 10, so it's a 2. So iota square is a 2 over 1 plus iota is my k. Fine. Is it fine? You can check your calculation. It's a whenever it's a 5 minus 5 iota is a 5 minus 10 is a minus 5 minus here and divided by this. So therefore your T inverse of W will be 2 over 1 plus iota W minus 10 over this value. Fine. Now I can move this portion to be here. Now look at the option. W is the mapping. Okay, I can choose this value from here. Take any value of W. Firstly, I can choose W is my Z. So this value is my fine. So what is the value of this? Z will be 0. So Z is my greater than 5. Fine, it satisfies this property, but we need a strictly less than 0, but it is equality. So this property is satisfied. 10 less than 5 not satisfied. 10 minus 5, 5 it's a boundary point. 10 minus 5, 5 is a boundary point. We can't say. Look at the any other pair. If I choose any pair of this, like of 5 plus 5 iota, fine, then what is the value of 5 plus 5 iota? W, what is the value of the Z is infinity, and the real part is less than 0, not satisfied. So what is that? What is the absolute value of this? It is a 5 root 2, which is not satisfied. What is that? W minus 5 is a 5 iota, again not satisfied. This value again not satisfied. So this value is not satisfied. If I choose any value strictly 5, not satisfied. 5 minus 5, 0. 5 minus 5. So one of them option may be discarded. So what is the value of the Z? 5 minus 5. It is a cancel out, minus 5 iota over 2 over 1 plus iota. So what is that? It's a 1 over iota. So that is my minus iota over 1 plus iota. So can you rationalize it? 1 minus, so what is that? It's a minus 2 iota plus minus minus plus 2 iota square divided by 2. So what is that? It's a minus 1 plus, sorry, minus 1 minus iota. Real part is less than 1, satisfied. So this value will satisfied on 5 minus 5, 0. This value is not satisfied. So this is the correct option for this. And for this case, you have to put up the one more example. So what you can do? If I choose omega, no. If I choose Z is my 0, the corresponding value of this is omega is 10. So if Z is 0, okay, this value is also discard. This value is already discard. If I take Z is not less than 5, this option is also discard. C is the only remaining which is satisfied. Look at this another one. Okay, you can choose any of the value. Say z is 0. Fine. If I take z is my 0, what is the t1 of 0? t1 of 0 is 2 over 3. So what is that t2 of 2 over 3? If I substitute here 2 over 3, 2 over 3 plus 1 is a 2 over 5. Fine. Now you can substitute z. It's not a 2 over 5. When z is 2 over 5, fine. It's a fine here. So none of this is mere cancel. Now you can choose any other pair. If I choose z is equal to 1, so what is that? t1 of 1 will be 3 over 4. t2 of t2 1. So 3 over 4 divided by 7 over 4. It's a 3 over 7. So when z is equal to 1, it is not 3 over 7. It is a 3 over 7. C is the right answer. Now you have to find the inverse. Again, I can take z is my say 0. What is the t1 inverse of 0? Definitely say w. So I can say 0 is my t1 of w. So what is the value of the w? When z is 0, w will be 2 over 3. So I can substitute this value here. Value of the z is out of this option. Check when it will come a 0. So this is 0, satisfied. This is 0, satisfied. This is wrong. This is wrong. Now I can choose any other pair. If I choose z is 1, so 1 will be my t1 of w. So when z is equal to 1, what is my w? It's a 3 over 4. So now I can substitute z is 3 over 4. Check whether it comes to be the 1 or not. So 2 minus 6 over 4 and it's a 7 over 4. 8 minus 6, 2 over 4, 7 over 4. It is not 1. 2 minus 6 over 4 is a 3 over 4 minus 1. It's a 8 minus 6, 2 over 4. It is my minus 1 over 4. Again it is not satisfied. So where is the error? When z is 1, it's a 3 over 4, fine. So if it's a, sorry, w is my 3 over 4. Sorry, it's a wrong. It's a 3w. It's a 3w. So it's a 2 minus 9 over 4. 3 over 4 plus 7 over 4. So 8 minus 9 minus 1 over 4, 7 over 4. It is not 1. Fine. 2 minus 9 over 4. W minus 1 is minus 1 over 4. So it's a 4, 8 minus 1 over 4 minus 1 over 4 is a 1. It's satisfied is the right answer of this problem. Look at this one. Again, I can choose any value. Say z is w. What is the t1 of 0? t1 of 0 will be my 2 over 3. So I can say this number will be my w. So it means I need to prove this value should be of here. Now t1 of 0, if I take z is my 0, what is my w? W is my here. W, okay, w is my t2. So what is the t1 of 0 is? 2 over 3. Fine. Now if I take z is 0, is it 2 by 3? No. No, sorry, it's wrong. If I take z is 0, what will happen of this? T1 of 0, it is my 2 over 3. Fine. Okay. If T1 is 0, then T2 inverse of 2 by 3. This is the target we have to find. Now what is the T inverse of this? If I found this is my W, fine. Can you find the value of W from here? This comes to be 1 minus W of this. So Z will be, so this is my T2 inverse. So what is that? If I substitute T2 inverse of W, it is my 2 over 3, 1 minus 2 over 3. So what is that? It's a 1 over 3. That's my 2. So this constant is my 2 is the, because Z is equal to 0, only answer 2 is my here. This is a simple way you can solve it. So B is the required answer of this problem. We will see the next lecture on this identity theorem and the Schwarz lemma. Till then, you can simply join my WhatsApp group, like, share and comments on my video. Best of luck, students. Happy learning.